Hello and welcome to our video for practice problems for chapter 1. I'm going to be going over the answers for our practice problems in chapter 1 with the assumption that you have read these questions and maybe you're looking for a reason of why you thought differently or got an answer wrong. So I'm not going to be reading every question out loud and going through. I'm going to be pointing out things to be looking for in the questions and then giving maybe some more background to it, but I'm not going to be reading all of the questions out loud. I'm just going to be going through the answers for them. If you ever want more explanation or something still confusing after the video, always please come contact me, visit me during office hours, email me, and let's get the confusion cleared up. So for number 1, it is true. Yes, we do often use sample data to form conclusions about populations. This is found on page 3 in your book. It starts off right away talking about that. Number 2, we're talking about an ordinal variable or an ordinal measurement here. So remember, an ordinal measurement or an ordinal variable is data that can be arranged in order, but the differences either can't be found or are meaningless. So we're looking at here, height in feet, well, that's not ordinal. We're looking at body mass index, that's also not ordinal. Ranks of colleges in U.S. News and World Report. Depending on how you look at that, yeah, that definitely could be ordinal. And then if we look at part D, annual income, well, that's also not an ordinal variable. All these values for A, B, and D are definitely going to have meaning between them. And C, if you think about how they're ranking colleges, it could be meaningless depending on what they're looking for, or you can't really determine the difference between the two. So the answer for number 2 is C, as the most considered ordinal variable. Number 3, we're looking at the big thing here is not a categorical or nominal variable. So remember, categorical or nominal is categories only. The data can't be arranged in any order. So when we're looking for a not, most of these are going to be categorical, and we're looking for one that's not categorical. Well, gender is categorical, so it's not A. HIV status, positive or negative, you can't really rank those in any kind of order, so that is also categorical. Diabetes status, type 2, yes or no, those are also, you can't rank those, so that's categorical. So the answer is D, height in centimeters. That is a value that is not categorical. Which of the following is not a main goal of biostatistics in research practice? The answer is C. Only report those values which indicate or influence observations. Remember, the keyword here is which one is not a main goal of biostatistics. Our goal is to not only report, we report all answers. We report anything, whether it's good or bad. We don't just pick and choose the ones we want. That is not a goal of biostatistics. We want to report all information, whether it's statistically significant or not. Number 5, which of the following is included as one of the founding principles that make up the guidelines for institutional review board or an IRB? Correct answer is D. All of these are needed and are used for an IRB and ethics when it comes to research. Number 6, keywords here, we're looking at an experimental and a placebo-controlled study. So if you read through these, number 1, you can cross number 1 off because it says non-experimental. We're looking for experimental, so non-experimental is not going to work. If you're looking at number D, a researcher is interested in the causal relationship between periodontal disease and hypertension, so they observe, keyword here, they observe the results from 10 different studies. So they're not experimenting, they're observing data that's already been done. That's not an experimental design. Number C, epidemiologists are interested in the association between mold and Holmes and wheezing in young adults, so they conduct an investigation looking at exposure and outcome relationship. Well, when they're just looking at the exposure and outcome relationship, they're not really testing to see what mold does to you for wheezing purposes. This is more of an observational design. And so when you look at number C is an experimental control because they start off with a clinical trial on a new chemotherapy to increase progression-free survival. It's randomly offered to half the participants while the other half receive best standard of care. When you say receive the best standard of care, that is their fancy way of saying it's a placebo. Moving on to number 7 here, we're looking at what kind of study design this is. So if we're looking, the main things we're looking at here at the very end is it says retrospectively. So when we see that something is retrospectively, we know that they're looking in the past at the data. And so the type of design this is going to be is observational. And specifically, it's retrospective. Keywords here, remember retro meaning in the past is something we consider as retro. It's looking at it in the past. Retrospectively, collecting data in the past, or looking at data that's been collected in the past. Part A here, we're looking to the study is mandated to be double blind. Describe the meaning of double blind as it relates to this particular study. So, double blind is neither the participants nor the physicians involved are aware of which treatments the participants will receive. I'm going to write that out after the video because I don't want to spend a minute writing that out for you. But remember, when we have a single blind, double blind, triple blind, all increasing in blindness. So when we have a double blind, neither the participants nor the physicians or nurses, the people that are involved, are aware of the treatment. Number 9, determine whether the given value is a statistic or parameter. So keywords here we're looking at, if we're looking at parameter or statistic, all, anytime we see all, that's going to be the parameter. The difference in number 10 is that when we collect a sample, that's not all of the values that are there, it's just a sample of what's going that you're collecting, so that would be a statistic. Number 11 here, what type of design is this? And we would say this is experimental. There's a lot of keywords here that can show that it's experimental. First, we're looking at conducting assessment of drugs' ability to reduce blood pressure compared to a control group. Well, we have a control group right there. We randomly select a group of 250 participants from the population and randomly send half them to receive the new study drug, right? So we're experimenting on that drug. And then the other half gets the saline solution, which should be the placebo part there. Results would be compared, and neither the patient, study, nor doctor, nor the monitoring board would be aware of the random assignment. So the type of blinding this is we would say this is triple level blinding. Part 12, determine which of the 4 levels of measurement is most appropriate. So here we're having doctors measure in weights, preterm babies. So here we have weights. So it's not a category. Weights are in a particular order, but their difference between them is meaningful, so it's not ordinary. It's either interval or ratio, and we know that weights actually have a true value of 0. So if we think of true value 0 and O for ratio, it is part D. Whereas in part 13, when we're looking at temperature is a different one. It's not a ratio because there is no absolute true 0, so we say it's an interval. Number 14 here, when we're looking at the species of hummingbirds, there's 17 different species here. Well, and then they list them, so they list them by their name. Well, that's not a ratio, right? Because the difference between them, I don't know how you compare, I don't know, an Anna to a black-chinned. I don't know the difference between them at all, and whether or not there is an order to them at all. So it's not a ratio, it's not interval, it's not ordinal. We consider this to be nominal data. It's categorical. Number 15. Here we're looking at the difference between cross-sectional, retrospective, and prospective. So here, where the researcher plans to follow children of service members who died in Afghanistan for the next 20 years. So here we're following children for the next 20 years, so we're going forward in time and collecting data, so it's going to be a prospective. Meanwhile, number 16, we're already collecting geese data from reports. So this data has already been done, and we're collecting it, and we're looking at it now, but it's from over the past 15 years, so this is a retrospective. Number 17, so we're looking at selecting every 200th home on the list. That is a systematic type of sample. If you want to read more about the different types of sampling, that's going to be on page 27, where systematic sampling is selecting every kth subject, so every 200 home or every 5th person or every other person. That's a systematic sampling. Same thing for number 18. You can find more on page 27 of the book. And here we're looking to obtain a sample of pregnant women. So a researcher contacts their school's preschool teachers for a list of names. We call this convenient sampling. Convenient sampling is using that as very easy to get. Most of the time, if you have younger kids, there's not going to be too much of an age gap between them, so you might be able to narrow down a list and find pregnant women a lot quicker, and it'd be easier to get. And once again, that's found on page 27 of your book. All right, so I kind of went through these. If you have any questions still, like I said, please email me, contact me. Make sure you tighten up all little areas that you might be confused on, and I will see you all in the next video. Have a great day.